In this work, we propose a rigorous benchmarking and performance analysis methodology for Python workloads. Scripting languages are increasingly popular, and in fact, Python is the third most popular programming language according to the TIOBE index. Unfortunately, rigorous methodologies are lacking. It's unclear whether prior work, for example, focuses on startup versus steady-state performance, and some of these prior works report geomean speedup numbers, and most prior studies, in fact, lack statistical data analysis. In this paper, we argue in favor of the harmonic mean speedup, and we provide a statistical argument as well as a physical argument against the geometric mean. We propose a statistically rigorous performance evaluation methodology to measure startup and steady-state performance, and we use this methodology to compare Pypy JIT compiler performance versus CPython interpreter performance. Does it really matter which mean we use in practice? Well, the answer is yes. We repeated an experiment from the Pypy website, and according to this website, using the geometric mean, one would conclude that the Pypy system leads to 4.4 times faster performance compared to CPython. However, if we use the harmonic mean speedup, we find that Pypy is 3% slower than CPython. So the question then is, which mean speedup is correct? And we argue in favor of the harmonic mean speedup. And moreover, we argue that one should make a distinction between startup performance and steady-state performance. So how should we measure startup performance? Well, what we propose is that you consider multiple VM invocations, and within each VM invocation, you consider a single benchmark execution or a single benchmark iteration. And the goal here really is to measure how quickly Python VM executes short-running programs. And this includes library loading and JIT compilation overheads. For steady-state performance, we would consider a single VM invocation and multiple benchmark iterations or benchmark executions. And the goal here is to measure long-running application performance as this relates to application code and Python VM optimization capabilities. Using this methodology, we then compare Pypy against CPython, and this graph is showing speedup versus CPython. So a value larger than 1 means that Pypy outperforms CPython for that particular benchmark for either startup performance or steady-state performance. Using this methodology, we conclude that Pypy outperforms CPython with a harmonic mean speedup of 1.7x. And for startup, Pypy is on par with CPython. In fact, it's 2% slower. In the paper, we provide various analyses to further analyze Python workload performance. So this is the short presentation, and I'd be happy to take any questions you might have.